Okay, so welcome back. We're going to continue with our analysis of the hemoglobin normal range workshop. This is the answer worksheet which I'll give to you. And really what we're looking at is defining a statistical analysis, looking at the difference and the significance of the difference between the two means of male hemoglobin and female hemoglobin. So I'm going to just create a new worksheet with our data set in, just to sort of kind of clean it up so you don't get too confused. I'm just going to paste this in here. Okay, so we now have our male and female data. So when we want to look at the differences and whether they are significant or not, we can use a t-test in order to identify that, particularly if we only have two sets of data. The thing that we need to do first, obviously this is assuming we've tested for normality, and so actually what we have is a parametric data set. So we've done the appropriate tests. We looked at kurtosis values and skewness values within our descriptive statistics. So if we go back to sheet 1, we have kurtosis and skewness here, and it satisfies other normality or tests for normality in terms of the sample set. So what we need to do then, obviously, is, or maybe not so obviously, is to utilize the data analysis toolpack. Now, one of the things that you'll note in the data analysis toolpack is we have 3 t-tests. And t-tests are useful for comparing sample means and seeing if there is any significant difference between the two sample means. So the first thing to note is when we are thinking about our t-test, is it a paired test that we're looking at, or are they two independent samples? In this instance, because we have a male and female, they cannot be paired because they're not from the same individual, right? So it has to be an independent. So we can exclude the paired two sample t-test. And so then we have to consider these two tests where we're assuming equal variance or assuming unequal variance. And so we need to do an initial test on our data set to see if there's any significant difference between the variance of the two populations of data. And the test that we use for that is the F-test to determine two samples for variances. So we have an input range request for male. We have an input range request for our female, so our two variables, I've added the labels. Our criteria for null hypothesis, or our significance criteria, is 0.05. And we're going to put the output range just here so that we can actually see it. So once we've selected everything, what we have is we now have an F-test. And the F-test is an important test to use to really look at how distributed, if you like, how wide or how broad the distribution of the data is, and whether that's going to affect the actual analysis, the statistical analysis. So if we just type out our null hypothesis, so H0 equals, there is no significant difference between the variances of the two data sets, Yeah, and obviously our H1 would be the opposite of that, right? So there is ... So our critical value, our critical significance value, we are setting at p equals 0.05. So our p-value has to be less than 0.05 in order to reject the null hypothesis. Okay, so when we look at our p-value for the F-test, and the F-test only assesses on a basis of one tail, we have a p-value, so our F, if you like, p-value is equal to 0.100, which is obviously greater than our critical significance value. So therefore, we have to accept the null hypothesis, which basically states then that there is no significant difference between the variances of the two data sets. So that then allows us to then make an informed decision about what is the appropriate t-test to use. So we need to identify what appropriate t-test we want to apply to our data set. So again, going back to the analysis tab, what we have again is to have a t-test assuming equal variance and a t-test two sample assuming unequal variance. So the one that we're going to select is equal variance. So we click OK, and obviously we've got our two variable ranges. So we've got male and we've got female. And we have labels, and our critical value is still 0.05, so that's the significance value, and our output range, I'm going to select this box here, and we click OK. So now we have our t-test for our two data sets. So one of the things that is different to the f-test when we're thinking about a t-test for looking at significance of difference, we always use the two-tailed significance value. So always this one in terms of identifying the p-value. There can be some instances where you would use only a one-tail, but in this instance we're only using two-tail because we're assuming a normal distribution, and actually this, what we're asking is at both ends of the scale, is the difference associated with a random event, or is it actually are we sure it's an observation? So what we have obviously our means, we have our variance within our means, our degrees of freedom, the t-statistic, and then assuming a two-tailed statistic, we have our p-value. So our null hypothesis, H0, equals, there is no significant difference between the two means of the two data sets, essentially. And our H1 will basically be, there is ... Obviously you should write that out fully. So our critical value, significance value, is again t equals 0.05, and so we're assessing our p-value to see if it is less than that. Okay, so our p-value for our data, p equals 8.75 e to the minus 10. Okay, so I'm just going to show what that actually means in real money. So if we do, so 8.75 e to the minus 10 is times 10 to the minus 10. Okay, so if I do this in essence in longhand, 0.0000000000875, and what you have is 8.75 times 10 to the minus 10. So this is significantly lower than p-value equals less than, or significantly lower than the p value of 0.05. In fact, actually, it's less than p equals 0.001, and so actually we'd assign normally a 4-star significance to this finding. So there is a significant difference between the means of the two populations of data, and that's an observed finding across the literature relating to male and female hemoglobins. So that's how we develop a t-test. We have to look at the variance of the data, we have to look at the parametric nature of the data, and then we can choose the appropriate test to ask questions about the significance level of our data sets. Okay, so I hope you enjoyed this final tutorial on our hemoglobin normal range data sets.